Hello everyone. So here's the next problem. So this problem has to deal with something called supernode. So what is supernode, first of all? So first, before you solve the any problem using nodal analysis, so first you have to choose the reference voltage, zero ground voltage, and this is your ground, right? And as you can see, one of the battery, one of the voltage source right here, 6 volt, is not grounded, right? And if one of the battery terminal is not grounded, it is called a supernode in nodal analysis language. So this you have three voltage sources here, right? And these two are one of the terminal for both 12 volts and 2 volt are grounded, so that's fine. But the 6 volt battery, none of the terminal is grounded. So then, if none of the terminals are grounded, we don't really know what's the exact voltage here and here. We know the difference in voltages is 6 volts, but these two voltages will be floating. Floating means they could be at any voltages. But we know the difference should be 6 volts, but we don't know the individual V1 and V2. So let's solve problems like that. It's something called supernode. And so again, after choosing the ground reference voltage, right, your next job is to figure out the unknown voltages, unknown node, right? So, and obviously you have two unknown nodes, only two actually, right? And because this is known, right? So this one, let's call V1. We don't know the voltage here, we don't know the voltage here, right? But we know the condition that V1 minus V2 has to be 6 volts, but we don't know the individual nodal points voltages. So this is at 12 volts, and this is at negative 2. Make sure you understand why this is at negative, because this battery is flipped, right? The positive terminal is grounded, so this point is at negative 2 volts with respect to 0 volts, right? And then it turns out there are only two unknown voltages, V1 and V2. And once you have V1 and V2, you can calculate everything, right? All the currents. And let's find that out. So this whole thing is called supernode. So this whole thing, this node, right, together is sometimes called supernode, right? This we can also call supernode. And then we can apply KCL at the supernode. But our first condition, let's apply at the supernode, something called supernode, right? Apply KCL. So this is, make sure to put all the positive and negative terminals based on the given current, right? Direction of the current, you have to put all the positive and negative terminals. So at supernode, what is the condition? So at supernode, this whole together called supernode, if you apply KCL, so it's going to be I1 is coming plus I2 is also coming, and then I3 is going. So that's the current, Kirchhoff's current law, right, at this supernode. I'm sorry, is no. So I1 and I2 and I3. So I3 is simply the current through the battery, but you can I4 plus I5. You can, at this whole supernode, you can say I1 plus I2 is coming, I4 and I5 are going, right? So you can write. So what is I1? I1 is 12 minus V1 divided by 6 ohm, right? Plus what is I2? I2 is, so 0 minus V1 divided by 4 ohm, right? So that's I2, because based on the direction of the current, this is 0 volt, right? And this is V1, so 0 minus V1 divided by 4. On the right hand side, what is I4? I4 is just V2 minus 0, which is V2 divided by 2 ohms, and plus what is I5? I5 is V2 minus 2, right, divided by 2. It's not just 2, it's negative 2, right? And now simplify that. So once you simplify this, so I'm just going to write down my simplified equation. So this is what I got in decimal places. 2 is equal to 1. Right. So this is my equation number 1. Right. So since you have two unknown variables v1 and v2, you need one more equations to solve this problem. So what would be the next equation? How do you get the next equation? So next equation is here. So the condition is v1 minus v2 has to be 6 volt, right? We know that because this battery voltage is 6 volts. So v1 minus v2 has to be 6 volts. This is my second equation. So now you can solve these two unknown equations very easily, right? You don't necessarily need to form in a matrix form because it has only two unknown variables. If you want, you can put them in matrix form if you want, right? So and just use the calculator if you want to save some time, right? 1 minus 1, and then you have the unknown v1 v2 goes here. On the right hand side is a 1 and 6, right? And if you solve this matrix, you're gonna get, so solve this matrix, 4.94 volts, and you will end up with this negative 1.06 volts, right? Okay, so that these are the answers, right? And once you have this, you can find all the currents, right? All the currents. So I1, I2, I3, I4, right? And I5. All this. So what is I1? So I1, back to the diagram. I1 is 12 minus V1 divided by 6. So 12 minus V1. So V1 is 4.94 divided by 6 ohm. And you're going to get I1 as 1.18 amp. What is I2? I2 is now, I2 is 0 minus V1 divided by 4, right? 0 minus V1. What is V1? V1 is 4.94 divided by, what is the resistance? Resistance is 4 ohm. Okay, so that's what I got. So is negative 1.235 amp. Right. Okay. Yeah. And what is I3? I3 is V1 minus, I3 is just I1 plus I2, right? I3 is just I1 plus I3, right? I1 plus I3, I2 is going to be just a second, negative 0.058 amps. I4 is V2 minus 0, right? So V2 divided by 2 ohms, and that's going to give me 0.52, negative 0.529 amps, because V2 turns out to be negative voltage. And finally, I5 is V2. What is I5? I5 is V2 minus negative 2. So V2 plus 2 divided by, what's the resistance? 2 ohm. And that's going to give me 0.471 amp. So if you see negative in the direction of the current here, this is negative current. That simply means the direction of the current shown in the diagram is wrong. It's just, you just need to flip it. The actual direction of the current is actually in opposite direction compared to the direction that you are given. You may be given any direction of current, and if the direction of the current is wrong, you will end up with negative current, but the magnitude remains same.